Greetings, my fellow teachers. This is Mr. Blynn, New York City math teacher and virtual content specialist. I've created videos and additional resources for this lesson, which I believe you find very useful as you do this lesson with your students. Unit 7, Day 11. This is a very interesting lesson. It begins with some explorations, open-ended questions, which are excellent. And then the students have some fun with this applet, and they can build and create their own shapes however they want, whatever side lengths or angle measures they want. However, they're asked to measure the angles and the sides and record their results here. This updated version includes mathematical symbols and an extra column so students can record their angle measures. So I invite you to use the document I made for you with these enhancements. I do also want to let you know about an additional slide, this slide right here, because with this applet here, it's hard to get the exact same triangle. Very difficult because the angles are measured to the hundredths place. We can't really move the segments so precisely. So this is 91.26, this is 91.25, this is 36.56, and this is 35. Even though we're not teaching this directly, we want the students to explore and really find out what makes two shapes the same. We want them to realize that congruent shapes have the exact same side lengths and the exact same angle measurements. Students could create a triangle like this one right here, which definitely is congruent to Jada's triangle, whose angles are not exactly the same. We do want students to discover when they have triangles with the same side lengths, they do get congruent angles and congruent triangles. The fact that it doesn't come out exactly that way from the applet presents a complication. Hopefully the resources here with the videos and extra slides will help students to work collaboratively and reach a consensus on how they want to proceed with the lesson considering this complication. Of course, they'll also get guidance from you, and hopefully this video will support you as well. With a quadrilateral, even the same side lengths, you can get different angles and therefore different shapes. They will not necessarily be congruent. We are not teaching this to them. We want them to explore this. However, the issue of whether something is identical came up because I can't even if I try, I can't make two shapes exactly identical. So I wanted to make that open-ended also for the students to explore. And so I added this slide here for students to then superimpose and then have a little discussion. For our investigation, are we going to say that if you can superimpose them that they are congruent or the same in geometry? I think it's a cool question and fun for your students and you to explore. Then in slides E and F, students will build shapes according to these exact specifications here, the exact dimensions. 4, 5, 6, and 9 quadrilateral, and Jada's shape, that was Diego's. And this is Jada's shape, which is a 4, 5, 8-inch triangle. One thing I definitely feel would be wonderful for your students to do is to take screenshots of the work they create here and then insert it into these slides like I've done here, and then compare by superimposing them to really see, are they identical? Because another question, of course, to explore is, well, do these shapes look the same? Well, they don't really look the same because they're not oriented the same. But if we make them transparent, click on the shape, format options, and make the shape more transparent. Here you can't do that. But if you make it more transparent, then we actually can superimpose. And in the videos, it shows the students. It actually shows the students how they can use these various settings to superimpose shapes one on top of the other, rotating them, etc. And even goes a little bit into scale drawings because the fact is this triangle has a measurement of 4, this triangle has a measurement of 4, but 4 is supposed to equal 4, but they're not equal because one's a scale drawing of the other one. So we don't want students to get so bogged down with that. One thing you could do is change the wording, and instead of saying are they identical or are they the same shape. But still, although it can pose some interesting questions, why not allow them to superimpose and get to the nitty-gritty of the lesson, which is about the triangles, the uniqueness of it, which we'll continue to explore in other lessons. So what I've done is I've created some videos showing students how they can manipulate these shapes, lock the aspect ratio, and then scale it down so they actually can compare these triangles one to another and determine for themselves if they think these triangles are congruent or not. So that's why I've placed this slide here in preparation for slide G. Another possible complication of the lesson is if you give the students all the slides, they may accidentally or on purpose go to slide G. They will see Diego's shape and Jada's shape, and that'll spoil the whole surprise. The whole surprise is that they create their own shapes and then they compare and realize that Everyone's going to make Jada's triangle, but everyone will not make Diego's. In fact, the likelihood of making Diego's exact quadrilateral without looking at it is pretty low, because there are so many different types of quadrilaterals that the students can make. And this is a very interesting thing for them to explore. So if they see slide G, it defeats the whole purpose of the lesson. Once they complete slides E and F, making sure they've already taken screenshots of their work, then they can proceed to slide G. That's why what I've done is created for teachers these separate slides, where here this is slides A through F only, and you can present this to your students. I'm going to give them a copy, give each of them a copy, depending on the modality you're using to share the documents. And there's also a slides G through K copy, which include preparatory slides so they can explore and compare the triangle that I made is the same as Alan's triangle. And then they can proceed to slide G, where they will take screenshots of their shapes and place them in the slide and then answer these questions. What they will do is they will have their screenshot here, and they can put this in here. And then using the technique shown in the video, they will be able to, using format options, transparency, and scale the drawings down to where 9 here is the same as 9 here, and 8 here is the same as 8 here, and then really compare. Log aspect ratio, scale it down. After students rotate, flip, and align the vertices of each shapes, they will look something like this. And then the students can really have a discussion with you and with each other about, is this what you thought these shapes looked like when you created them? And which copies were identical? Now you can see identical. Clearly the triangle is identical. And examine your drawing of Diego's shape. Why do you think you did not make an identical copy? Matter of fact, you can share other students' quadrilateral, and you can see that the quadrilaterals came out to be wildly different, whereas the triangles all approximately were equivalent to Jada's, and for all intents and purposes, even the angle measures aren't exact, are congruent triangles to the best of our abilities considering the technology of the applet. The copies that I've shared with you also include some additions and supports for slides H and I. Slide J has a wonderful cool-down, summarizing question, or can be used for homework. These resources, these slides, are shared with educators as viewers. In order to share with your students, it's very important to click File, make a copy, entire presentation, title it however you'd like, of course, and this will allow you to share this document with your students and also make any edits you need to meet their needs. My colleagues, I sincerely hope you and your students enjoy these resources.